In this lesson, then, we're going to do a quick review of some of the concepts we've learned earlier about memory processing. For instance, we've learned about working memory, a short-term, limited capacity system, but whatever's in working memory has the potential to be transformed into a long-term memory stored in the cerebral cortex. And that transformation was a process called consolidation, and the hippocampus and surrounding tissue was a critical component of that process of consolidation. So we'll begin with the hippocampus. Here's the hippocampus tucked underneath the temporal lobe. Here's a cross-section of a human brain showing the region of the hippocampus. And here the human brain has been stained, so the little purple things are brain cells. So here's the hippocampus again down there. Now let's imagine we're having a learning episode. And the episode for the remainder of this lesson will be we're in a classroom, we're on the microscope, so we're feeling the microscope and the knobs, and we're changing focus, and we're observing amoeba and paramecia. So amoeba is a single-celled predator, and it eats paramecia. And we might also be hearing, perhaps the teacher is saying, amoeba extends pseudopods to engulf prey. So here are the pseudopods right there, extensions of the cell membrane. So notice then there are different sensory aspects of that learning experience. You have auditory, you have tactile, touch, and you have visual. So the sensory and perceptual regions of the brain are processing the different aspects of the experience. And then we learned that those regions of the brain all send information to the hippocampus. So there's convergence in the hippocampus. So here we have the hippocampus down here in magnification. So the sound of that verbal description, the feel of the microscope, the sight of the amoeba, all are converging on hippocampal cells. And what the hippocampus is going to do here is sort of link those different sensory aspects of the experience to form a memory trace. So we say a memory trace of the learning episode is established in the hippocampus. It's hippocampal cells that are responding to the learning event, and they're changing. They're physically changing. They're biologically changing the strengths of connections, as we'll see in a moment. But that's going to be our icon for the hippocampal memory trace. So again, it's connecting the different perceptual features of the episode, including the circumstances of learning. So we're going to call this an episodic memory trace. And remember, the circumstances of learning have to do with the details of the learning experience, what it felt like to touch the amoeba or to touch the microscope, what the amoeba looked like, how you felt in the classroom, and just remembering with vividness somebody saying amoeba extends pseudopods. So again, we want to think of an episodic memory as kind of remembering the vividness of the circumstances of learning. Now, a different learning episode would have activated a different set of hippocampal neurons. So the hippocampus stands ready to link sensory aspects of different events using different hippocampal neurons. And we'll see the significance of that a little later on. Now, let's bring in the concept of synaptic plasticity. So let's consider the situation before learning has occurred, and we're going to look at synapse strengths in the different cortical regions. And we'll say that initially we have some baseline synaptic strength in auditory cortex neurons that are going to be processing the learning event. A baseline strength of synaptic connection in the touch cortex neurons. A baseline level of strength in the connection between visual neurons, etc., right? And here we have in the hippocampus. So before learning, there is some baseline level of synaptic strength in the neurons that are going to be processing the learning event. Now, after learning then, so activated synapses get stronger, and significantly so in the hippocampus. So in the hippocampus, the idea, we've talked about this LTP, long-term potentiation, there is a significant increase in synaptic strength among the neurons in the hippocampus that took part in the learning episode. So when we think about this episodic memory trace being formed, we want to think about LTP happening here, synaptic plasticity. The synapses get stronger among certain sets of hippocampal neurons, and that is the basis of the memory trace in the hippocampus. But notice up in the cortex, we also have some synaptic plasticity, but it's a smaller change. Right, so in the auditory cortex and in the touch cortex and in the visual cortex, it's a smaller magnitude of synaptic enhancement. It's the hippocampus where we see significant synaptic plasticity. And just to quickly review, scientists suspect that what's going on, in fact, they don't just suspect, they have good evidence that what's going on at the level of synapses in the hippocampus is the hippocampal cells are inserting more receptors into their membranes here at the target neuron. So this would be the dendrite of the target neuron, and here's a spine. And what the cells seem to be doing is increasing very quickly the number of receptors in the membrane here, so that for a given amount of neurotransmitter, there's a larger electrical signal. So that's an enhancement of neural communication between the two cells. And then over a longer period of time, we have the growth of the spine. So the synapse, the junction, can become larger, and those kinds of changes may be maintained for longer periods of time, the basis of long-term memory. But back to the learning episode then. Initially then, we have a strong memory trace in the hippocampus, but the changes in the cortex, the plasticity that happened in the cortex, was of a smaller magnitude. So we're going to call that weak memory traces in the cortex. The significance of this then would be that the hippocampus is still necessary at this early time for retrieval at this time, because the cortical memory trace is weak. And you'll recall that for patients like HM who had their hippocampus removed, he couldn't retrieve events that happened just prior to the surgery. See, because those kinds of events would have required the hippocampus for retrieval. So let's see what happens then right after learning. What happens when somebody asks us to retrieve information from that learning episode? Suppose somebody says, "What do you know about amoeba?" Well, that is going to come in through the auditory channel. You just heard somebody say that. Of course, because you're conscious of it, it's in your working memory, but the auditory cortex is going to be processing that sound from that person who just said it. Now that cue, we'll call that a cue, it's a retrieval cue. The cue reactivates the cortical cells that process the original learning episode, and those cortical cells reactivate some of the hippocampal cells that formed the strong memory trace of the episode. So notice what's happening here. We already established a memory trace of the learning episode about amoeba, and now maybe the next day somebody says, "What do you know about amoeba?" We're going to reactivate, because the amoeba here, that was a previously learned thing the other day. That's going to reactivate some of the very same cells that were involved in the initial learning, and so we have a chance now of reactivating the memory trace in the hippocampus. And scientists call this pattern completion. Because here's what's going to happen. The activated hippocampal cells reactivate the entire set of hippocampal cells that form the strong memory trace. So you see, this was just one auditory pathway. Remember, the hippocampus linked together the touch of the microscope and the sight of the amoeba, but here we're just triggering a retrieval event from the auditory channel. So that's the green cell here. But the activation of this cell then, because of the synaptic plasticity, that cell, when it becomes active, it can reactivate the rest of the memory trace in the hippocampus. And then the hippocampal cells, when that memory trace is reactivated, those cells then can go on to reactivate the other cortical neurons. So those were, again, the cortical neurons that were involved in processing the original learning episode in the first place. So you see, it was through the auditory channel. The entire hippocampal memory trace gets reactivated, which then can reactivate the cortical memory traces. So remembering the hearing about pseudopods and the sight of the amoeba through the microscope. Now notice I didn't put the microscope up here because the question was, what do you know about amoeba? And so it's not as if that information about what the microscope felt like in your hands is relevant to answering the question. However, what you heard about amoeba is relevant to answering the questions, and what amoeba look like and what you saw them do is relevant to answering the question. So I'm just going to put those two instances on the brain at this point. And we're actually, in the future, we're going to let the tactile feel of the experience, we're going to let that be the icon for the vivid, detailed episodic memory of the learning event. So we're going to let the touch part of the memory stand in for the episodic memory, the circumstances of learning. So again, early on then, the hippocampus is necessary for retrieval because the synaptic plasticity that occurred in the cortex was of a weaker nature than in the hippocampus itself. So if we're going to retrieve information about some recently learned information, we're going to need to reactivate the hippocampal memory trace and use that as a cue, as an index, to reactivate the cortical memory traces. Now suppose somebody had said, do you remember learning about how amoeba eat? Now this kind of question invites us to retrieve the more sort of vivid, detailed, context-rich kind of memory. We'll call that episodic retrieval. Notice then we have the microscope being activated here. So we're going to call this then the circumstances of learning. And the hippocampus is required then for reactivating all these components of the learning episode so that we can have that vivid recollection of the learning event. So when the circumstances of learning can be recalled, we're going to call this episodic retrieval, a context-sensitive, detail-rich, and vivid recollection of the learning episode. If the circumstances of learning are not retrieved, but information about what was learned can be retrieved, we're going to call this semantic retrieval. So again, notice the microscope has disappeared here. It's this question, what do you know about amoeba? And so we'll be activating the relevant semantic memory about what amoeba look like and what they do, and you heard facts about the amoeba. So again, the difference between the episodic retrieval, we can retrieve the circumstances of learning, but notice that's usually triggered by a different type of question. And then we have semantic retrieval, where we're just accessing facts about amoeba and not so much the details of the learning circumstances.